Hello friends, in this session we will learn about the geometric design of highways. The phase of highway design which deals with the visible elements of different highways such as alignment, sight distance is called as geometric design of highways. If you like the video, please do share it and subscribe the channel. In the last slide we have learned definition of geometric design of highways. Now we will learn its meaning. 1. It deals with the dimensions and layout of visible elements of the highways. 2. To have maximum efficiency in traffic operation with safety and economy. 3. Once fixed, it is difficult to change these, so extreme care is necessary while designing these for present as well as future needs. Now we will see elements of geometric design of highways. 1. Cross-sectional elements are width, formation, surface, slopes. 2. Sight distances, for safety in stopping and overtaking operations. 3. Horizontal and vertical alignment, curves, radii, super elevation, widening. 4. Intersectional elements, radii, islands. Now design controls and criteria. 1. Factors on which geometric design of highways depends are as topography, locality, traffic characteristics, requirements of speeds, vehicle types, economy, climate. 2. Controls required to study are as design speed, topography, design vehicle, design volume, environment, and class of road. Geometric design of highways depends on the type of construction, materials used, funds, traffic and climate. The important surface characteristics are as 1. Friction. 2. Roughness. 3. Light reflection. 4. Drainage. 1. Friction governs the operating speed and distance for stopping and accelerating vehicle. 2. If friction is less, skidding of vehicles occur. If loose, muddy or wet, slipping of vehicles occur. 3. Aggregate type and mixed design govern the skid resistance. Recommended values as per IRC are given in the slide. Even and smooth surface permit high speed while uneven, rough reduce it. Cost, comfort, and safety are affected. Fuel consumption, wear and tear of tires is more. Unevenness index is the cumulative undulations per unit horizontal length. IT is expressed as centimeter per kilometer. IT can be measured by Benkelman beam or Merlin. The IRC specifications are also given. Light reflection. 1. IT governs the visibility. 2. If too much, causes glare and eye strain. If too less, driving becomes unsafe. 3. IT depends on the materials used, time of day or night, intensity of natural or artificial lights. 4. Black tops, daytime, concrete, night. Camber means cross slope. 1. The slope of road surface in transverse direction. 2. IT is useful for drainage of rainwater, appearance, regulation of vehicles. 3. IT is expressed as 1 in N or in percentage or vertical to horizontal. 4. IT depends on amount of rainfall, permeability of surface. If too much, it causes tilting of vehicles and discomfort, unequal pressures on tires, wear at central portion, high-speed water causing ruts. In this slide the types of cambers and their recommended values as per IRC are given. Now we will learn carriageway. 1. It depends on width of single lane and no of lanes to be provided. Width of single lane depends on maximum width of the vehicle and clearance required on sides. 2. As per IRC, width of design vehicle is 2.44 meter. And clearance of 0.655 m makes lane width to 3.75 meter. For multiple lanes 3.5 meter per lane is adopted. 3. Number of lanes depend on traffic volume and lane capacity. Road margins include components like shoulder, parking lane, frontage of road, driveway, cycle track, footpath, guardrail, Embankment slopes. Now we will learn margins. Shoulder, serve as emergency lane for vehicles compelled to move out of lane. Minimum width 2.5 meter, desirable 4.5 meter. Parking lanes, provided in urban roads to allow side parking either parallel or angle. Frontage roads, to give access to properties along important highways, may run parallel to main highway and isolated by separators. Driveways, connect the highway with commercial establishments like fuel stations, service stations, hotels. Designed and located away from intersection and has enough radius of curvature. Cycle tracks, if bicycle traffic is more, special track of min 2 meter width for single lane and 1 m for each extra lane is provided. Layout requires careful attention at junctions. Footpaths, for pedestrians in urban area, minimum width 1.3 meter, more if volume is more. Surface smoother than pavement. Guardrail, for high embankments, greater than 3 meter, stones or rails provided to prevent fall down of vehicles, persons. Embankment slopes, should be as flat as possible for safety and aesthetical appearance. Gradient is the slope along the length of road, expressed as 1:50, slope, or in 2% or 10-degree angle. Required for easy drainage of rainwater. Factors, topography, nature of traffic, rainfall, drainage characteristics, surface type, safety, and economy. Types, ruling, limiting, average, floating, minimum. Types of gradient are as below. Ruling gradient. Limiting gradient. Exceptional gradient. Ruling, normally adopted grade. Generally this value is not exceeded. Value suitable to all types of vehicles. Power or animal. A gradient steeper than ruling, which can be used for restricted length only, is limiting or maximum gradient. Gradient steeper than limiting, which may be used for very short lengths, 60 m per km, only in exceptional cases, is exceptional gradient. Total rise or fall bet any 2 points divided by length between them is average gradient. The IRC specification for gradient and different topographical conditions are given in tabular form. Typical cross-section of road is shown in figure. Roadway or formation width. Top width of highway in embankment or bottom width of highway in cutting, excluding the side drains. Right of way. The area of land acquired for construction and development of road along its alignment. Depends on importance, future development, availability, and cost of land. Sight distance is the distance open to the vision of a vehicle driver. The driver must have visibility for certain minimum distance along the road to avoid accidents. Depending on situation, different types. 1. Stopping sight distance. 2. Overtaking sight distance. 3. Intersection sight distance. Factors affecting stopping sight distance. The distance within which a vehicle can be stopped depends on total reaction time of driver, speed of vehicle, efficiency of brakes, friction between road and tire, slope of road surface. Reaction time is the time spent from the instant the obstruction is visible to the instant the brakes are effectively applied. It is divided in 2 parts. Perception time, the time required to realize that brakes must be applied. Brake reaction time, time required from the realization of danger to the actual application of brakes. Total time may vary from 0.5 to 4.0 seconds depending on complexity of situation. PIEV theory for reaction time. Perception time, time required to perceive the danger, sensations passed to brain. Intellection time, time required to understand, compare and grouping thoughts. Emotion time, time for passing emotional sensations like fear, anger, or other feelings. Volition time, time taken for final action. Breaks may be applied by reflex action also. Depend on physical, psychological, environmental, and temporary factors.